For almost the whole of human history, the most important object in the sky was the one thing you could never actually look at. The sun gives us everything, including light, warmth, seasons, and the day itself, and yet you cannot study it. Try to look directly, and it simply burns the image out of your eyes. This is the strange trap we were born into. Every other star in the universe we could examine at our leisure in the safety of the dark. Our own star that keeps us all alive sits locked behind its own glare. It hides itself in such a way that we can't make out its edge, nor see the faint atmosphere around it. For most of history, we could not even say, with any real confidence, what it was made of. Except for a few minutes, a few times in a decade, when something slides in front of it and switches the glare off. The moon is about 400 times smaller than the sun, and, as luck would have it, it also sits about 400 times closer to us. So from where we stand, the two happen to look almost exactly the same size in the sky. Nothing in physics requires that. There is no law that lines those numbers up. We have simply decided to call it a coincidence, and, as we'll see, it's a temporary one. But for the slice of time we happen to be alive in, it means the moon can cover the sun almost perfectly. And for 2 dark minutes, it hands us the one thing we were never meant to have, a clear and safe look at our own star. Almost everything we know about the sun, and some of the deepest things we have ever learned about reality itself, we were able to discover them in those stolen minutes. This is the story of what humanity found in the dark. It starts in 1868, during a total eclipse over India. Astronomers there aimed a fairly new kind of instrument at the blacked-out sun. They didn't use a telescope to look closer. Instead, they used a spectrometer, a device that splits light into its full spread of colors. And this matters because you'll often find the fingerprint of what a thing is made of by exploring the exact colors that specific thing gives off. Every chemical element, when it burns, glows in its own unique set of sharp and colored lines. No two are alike. If you read in between the lines, you will be able to name the substance even if that substance is millions of miles away, sitting on the surface of the star. So as they spread out the light peeling off the sun's edge that day, they were reading its ingredients, one line at a time: hydrogen, iron, elements they knew. And then, a bright yellow line that matched nothing. Nothing on Earth produced it. No known substance anywhere fits. Let's hold on to that thought for a moment. There appeared to be something inside the sun that had never once been found on our own planet. An ingredient of our nearest star that was, for all anyone could tell, completely alien to the world beneath their feet. An English astronomer named Norman Lockyer made the bold call. He concluded that this was a new element, one nobody had ever held. He named it after the Greek word for the sun itself, helios. He called it helium. And here is the part that should stay with you. For the next 27 years, helium was a substance that existed only in the sky. It would take until 1895 before anyone managed to capture a single trace of it here on the ground. We knew one of the ingredients of the heavens decades before we knew it was also sitting inside the Earth, and we learned it by reading the colors of an eclipse. But the darkness had more to show us than that. With the blinding face of the sun finally blocked, astronomers could see, clearly, the thing that had always been hiding in the glare. A vast, pale crown of light streaming millions of miles out into space around the black disk of the moon, the corona. The sun's outer atmosphere, utterly invisible on any ordinary day, was revealed only in the deep shade of totality. And when, in time, we managed to measure how hot that crown was, the answer refused to make sense. It still, honestly, doesn't. The surface of the sun burns at around 5,500 degrees. Even the corona floating above that surface is also very intense, despite being farther from the core and farther from the furnace driving the whole thing. It is hotter, and it's not by a little. It is so hot that it climbs past 1,000,000 degrees. Think about how backwards that is. It is as if you stepped away from a bonfire and felt the air grow hundreds of times hotter the farther back you walked. How the sun manages to heat its own thin atmosphere to that impossible temperature is a genuine mystery. It's a problem physicists are still working to fully crack today, and we would never even have known there was a question to ask if the moon had not, for a few minutes, pulled the curtain across the sun. But the single greatest thing an eclipse ever gave us was not a fact about the sun at all. It was a verdict on the entire universe. In 1915, a physicist in Berlin named Albert Einstein finished a theory that made an outrageous claim. For more than 2 centuries, Isaac Newton's picture of gravity had stood untouched. Gravity was a force, an invisible pull reaching across empty space and drawing every mass toward every other. Einstein said that was wrong. He said gravity was something far stranger. He said that a massive object actually bends the fabric of space and time around itself, and that things fall not because they are pulled, but because they are following those curves in a warped and invisible landscape. It was a breathtaking idea. It was also, to almost everyone, an unbelievable one, and to make it worse, it seemed impossible to ever test. But the theory made one prediction you could, in principle, catch in the act. If space really does bend around a heavy object, then the light of a distant star, skimming past something as massive as the sun, should bend along with it. The star's apparent position in the sky would shift by a tiny but exact amount as its light curved around the sun on the way to our eyes. There was just one problem. To catch a star sitting right at the edge of the sun, you would need the sun's overwhelming light to somehow be gone, which meant there was exactly one moment in all of nature when this test could ever be attempted: a total eclipse. So in 1919, a British astronomer named Arthur Eddington sailed to a remote island off the coast of West Africa called Príncipe and set up his cameras to try. As the eclipse approached, clouds rolled across the sky and very nearly ruined the whole expedition. But in the final minutes, the sky broke open just enough. He captured his photographs. These photographs consisted of faint stars caught in the sudden darkness right beside the hidden sun. Then he measured exactly where those stars appeared to sit and compared it to where they truly belonged. The starlight had bent, by almost precisely the amount Einstein had predicted and by twice what Newton's physics could ever allow. 200 years of certainty about gravity came apart in a single afternoon, and it was decided by a photograph taken in the shadow of the moon. When the result was announced to the world, the reaction was like nothing science had seen. Albert Einstein, a man the general public had barely heard of the week before, woke to find himself the most famous scientist alive. His name and his face splashed across the front pages of newspapers around the globe. An eclipse had overturned gravity and made a legend overnight. Now take a step back and look at the shape of the whole thing. An element unknown to Earth. An atmosphere hotter than the fire beneath it. The bending of starlight that tore down Newton and remade our understanding of space and time itself. Every one of those arrived through the same narrow 2-minute doorway. A doorway that exists only because of a coincidence that did not have to happen, on what appears to be the only planet where it happens at all. And that doorway is closing. The moon is drifting away from the Earth a little more every year by nearly 4 centimeters. That's roughly the rate your fingernails grow. Grain by grain, the perfect match that makes totality possible is slipping out of true. In a few 100 million years, the moon will hang too far away to ever fully cover the sun again. There will still be eclipses. But never again this. Never again the complete darkness that lets us look our own star in the eye. The door that gave us helium and the corona and relativity will close, and it will not reopen. So let's hold the full picture for a moment. Of all the stretches of time in the history of the universe, we happen to be alive in the slim one where this still works. Of all the worlds out there, we happen to stand on the single one where it lines up. And inside that lucky closing window, a curious animal woke up, looked at 2 minutes of accidental night, and instead of only cowering from it, used it to weigh the ingredients of a star, to uncover a mystery still burning above the sun, and to catch the universe in the very act of bending light. We were handed a door that will not stay open forever, and we walked through it and came back carrying the laws of reality in our hands. On the 12th of August 2026, that door swings open again. The moon's shadow will race across Greenland, sweep over Iceland, and fall onto the northern coast of Spain as the sun drops toward the sea. And for about 2 minutes, in the middle of the day, the sun will vanish, and its ghostly crown will blaze out across a darkened sky. Millions of people will look up. Most will feel the old awe at the dark. But maybe, now, you'll feel the deeper one. Because that same handful of minutes, that same accident of shadow is the exact door through which we learned what light is made of and what space and time truly are. The wonder of an eclipse was not only that the sky goes dark. It's that a small, curious species, who were handed a few borrowed minutes of night, reached straight through them and read the universe. If the hidden machinery behind the world does something to you the way it does to us, come along. Subscribe to Numen. There is so much more waiting in the dark.